ladies and gentlemen. This is What Are Waves and Correlates with Chapter 14.1 in your textbook. Your key concepts for this video are, what are the two types of waves? What forms mechanical waves? What are the types of mechanical waves? And what are the properties of transverse and longitudinal waves? So, what are the two types of waves? When we talk about waves, we talk about two main types. The one we'll be looking at in this video and for the next week or so are mechanical waves. The other type are electromagnetic waves. We'll be looking at these later on. So first off, we're going to focus on these mechanical waves. So there's a couple things you need to know about them. Mechanical waves are waves that require a medium to travel. When I say medium, I'm not talking about a psychic or not a small, not a large. I'm talking about material for the wave to travel through. This can be like a solid, a liquid, or a gas. This is in fact why, as I've mentioned in class, there is no sound in space, because the medium, those atoms, are too far apart for the sound to vibrate between them. So the medium isn't really there, so sound doesn't travel in space because sound is a mechanical wave. So what forms mechanical waves? Waves are simply a disturbance that involves the transfer of energy. So when I am speaking, my vocal cords are disturbing the air that's in my throat and vibrating that, which is disturbing all the other ones, which is then traveling to you. Or imagine that I'm standing by a pond, I've got a rock, and I drop the rock into the surface of the pond. The pond was smooth, but now it's got all these waves and ripples traveling because I caused a disturbance that's moving that energy from where I put the energy and sending it out in all directions. And if you unfortunately are on a boat as another boat passes, the waves from the wake will tip you back and forth because it's a disturbance. So what are the types of mechanical waves? We've got three main types, and we'll mostly focus on two. One of them is a transverse wave. The second is a longitudinal wave. And the third is a surface wave. Now in this video, we're mostly going to be focusing on transverse and longitudinal waves, but be aware of surface waves as well. Surface waves are kind of a combination of both transverse and longitudinal. They move in a circular fashion. So instead of going up and down or forward and back, they go around. Let's look at transverse waves more in depth. If you've ever been to a sporting event or a pep rally or anything, and you've seen a crowd of people do the wave, you're observing a transverse wave. Because originally everyone's sitting down, and then the wave comes through. People stand up and sit back down right in their same seats. So that vibration of energy is traveling perpendicular to the direction of travel, because that wave is traveling around the stadium, but people, the particles, are moving up and down as they do the wave. So it's a perpendicular travel. And there's two parts of a transverse wave that I really need you to know. The first is this top part of the transverse wave. This is called your crest. It's the highest point of the wave from that mid or rest line. Then you've got the opposite, the bottom part of the wave, and this is called your trough. You can think about this like waves at the beach. The top of the wave is called the crest, and I imagine troughs, because imagine if you were an animal, you've got those feed troughs, and they look like little V's. The bottom here reminds me of little V's like feed troughs. Let's talk about longitudinal waves now. Longitudinal waves, so remember transverse waves went up and down, longitudinal waves move perpendicular to the direction of travel. So sound is a longitudinal wave. In earthquakes, you get the first wave, those primary P waves, those are longitudinal waves. So the energy is moving back and forth this way, and the wave is traveling in a parallel direction. And there's parts of longitudinal waves you need to know as well. Where the particles get squished close together, that's called compression. And it's just simply because they're compressed together. Now when they're pulled apart, that's called rarefaction. And this is where the medium is simply stretched apart. That's it. Be sure your notes hit all the key concepts and vocabulary, and feel free to try this challenge question.